So, we talked in our last video about this concept of a phase shift, and so now I want to illustrate what that actually looks like graphically, because previously we only talked about how to recognize a phase shift algebraically. So let's consider the graph of y equals cosine of 2x, and so the period is always going to be 2 pi over b. Our b here is 2, and so our period is going to be pi. So if I graph, y equals cosine of x, that's going to look like the following. I'll start at 1. I'll go to pi over 2, go to pi, 3 pi over 2, and 2 pi. So this is the graph of cosine of x. Okay, and so if I'm graphing y equals cosine of 2x, I'm going to be having a period of pi instead of 2 pi, so everything's going to kind of shrink horizontally. So I've already plotted my points to help myself out. So this is the graph of cosine of 2x, y equals cosine of 2x, versus the graph of y equals cosine of x. Now, if we want to graph y equals cosine of 2x minus pi, what's happening? What does this phase shift do? So I've shown you the work here, and what's happening is that we get a phase shift of pi over 2. And once again, we get a period of pi. So notice that having a phase shift does not affect the period of the graph at all. All it's doing is shifting the graph. And so because pi over 2 is positive, I'm going to shift my graph to the right. And so this is going to look like the following. Everything's going to get moved over pi over 2. So I'm starting off at x equals 0. Everything's going to shift to pi over 2. So my first point is going to be here, and it's going to move down and up. So if you notice, everything got shifted pi over 2 units. Shift pi over 2 units. Okay, and so this graph in blue will be y equals cosine of 2x minus pi. So this phase shift, once again, is just a way to shift the graph horizontally. Okay, and so we're just adding one extra layer to the shifts and the stretches that we've done up to this point. So now let's put this all together. If we have a graph of y equals k plus a cosine of bx plus c, or y equals k plus a sine of bx plus c, the following things are going to happen. This k constant is going to represent a vertical shift. So it's going to move our graph up or down on the y-axis. Our a is our amplitude. That's how far we're getting away from the x-axis. We've established that the period is 2 pi over b, so how long it takes cosine or sine to make a full revolution. And then this newest thing is our phase shift. It's our horizontal shift, and there's two things that we should note. If our phase shift is greater than 0, so if it's positive, we're shifting our graph to the right. Whereas if it's negative, so if it's less than 0, we're shifting our graph to the left. So if we go backwards, our phase shift in this particular example was pi over 2, and that's positive, which is why we shifted our graph to the right. So if I just kind of use a different color here, maybe green, positive, we shifted it to the right. Okay, if that had been negative, we would have shifted it to the left. So now let's do an example. One thing I want to do is we're going to graph something of the form k plus a sine of bx plus c. So we should identify that a is going to be negative 3, k is 1, b is 2, and c is pi. So that's going to give us an amplitude of, let's see, of the absolute value of negative 3, which is just 3. Our period is 2 pi over b, and b is going to be 2, so we get 2 pi over 2, so just pi. So let's kind of circle these. And our phase shift is negative c over b. So c is pi, so we're going to get negative pi, and B is 2, so negative pi over 2. So this is our phase shift. And this phase shift is negative, so it's a shift to the left. So I'm just going to kind of write out everything that's happening. We have our original graph, sine of x. This is our original function, okay? And we all know what that looks like. When we transform this to sine of 2x, what we're doing is we are horizontally shrinking the graph by a factor of 1/2. So this is going to be a horizontal shrink by 1/2. Because what we're doing is we're changing this from a graph where the period is 2 pi to a graph where the period is pi. So it's going to shrink. Next, we're going to apply this phase shift. So we're going to now, this is going to transform into sine of 2x plus pi. So that's going to be a phase shift to the left, pi over 2 units. And it's to the left because this is less than 0. Negative pi over 2 is less than 0. And then what do? So what I'm doing is I'm deconstructing this original graph or function y equals 1 minus 3 sine of 2x plus pi into all these pieces. So the next thing we would do is we have this negative sine of 2x plus pi. So this is just reflection across the x-axis. So whatever we have here, sine of 2x plus pi, we're just reflecting across the x-axis. And then we are going to apply this amplitude. So the amplitude is -3. We've already accounted for the negative by reflecting, and so we're just going to stretch the graph vertically by 3. Okay, and then finally, we've done all of this. We're at the thing that we're trying to graph, and we just need to shift this vertically by 1 unit. Okay, so this is just kind of a deconstruction of all of the things that you're doing to sine of x to get this graph right here. So let's see what that looks like with an example. So we're going to take this y equals 1 minus 3 sine of 2x plus pi. That's our goal. So I should write that somewhere up top. Y equals, let me change my font size really quick so I have some space. So we've got y equals 1 minus, and then let me remind myself, 3 sine of 2x sine of 2x minus pi. Let me just confirm that this is correct. 2x plus pi. Okay, so if you look, I've already got the graph of y equals sine x. So the next thing I want to do is build this up into this graph right here at the top. So the next thing I'm going to do is I'm going to graph y equals sine of 2x. So we've already established that this is going to be a new graph that has a period of pi instead of 2 pi. So this graph is going to shrink by a horizontal factor of 1/2. So this is going to be the graph of, y equals sine of 2x. So now we need to incorporate our phase shift. The phase shift was negative pi over 2, and so that's how much we are going to shift the graph over. So we're going to shift this over negative pi over 2. So now it's going to start here. We're going to shift pi over 2 to the left. Okay, so now we're going to be here, 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 and here. So that's our new graph. We've shifted it pi over 2 to the left. So now we need to flip it across the horizontal axis. And so I'm actually going to erase this shift just so that it doesn't get in the way of the rest of my graphing. Okay, but we're going to reflect this across the x-axis. So what color should we use for that? Let's use pink. or yellow. So we're going to reflect this. So now we've got a point here. These intercepts stay the same, and then this point let's see, pi over 4 and -1 is going to go up here. So we get the following. We flip everything across the x-axis. So this, and I need to keep track of my function. So this is y equals negative sine of 2x plus pi. And in the orange here, this was the graph of y equals, here I'll write this on the other side, y equals a positive sine of 2x plus pi. Okay, so now the next thing we want to do is we want to stretch this by a factor of 3. So our x-intercepts are going to stay the same. So at negative pi over 2, 0 and pi over 2 we're cool. But at our here, this coordinate is going to stretch by a factor of 3. So if we're at -1, we'll now be at -3. And here, if we're at a +1, we'll now be at a +3. So that's what's happening. These points are going to get stretched. So now we graph our new function like so, and this is going to be y equals -3 sine of 2x plus pi. And we are almost done. All we need to do is add 1. So, drum roll please. We just need to take our function where it's at, and we're shifting it up 1. So if I take this point right here and move it up 1, I'll draw a little horizontal line that represents where the shift is going to be. And actually, let's do this horizontal line with respect to the, well, no, what I have is fine. Okay, so this is going to shift here, up 1. This will shift up 1 right here. The x-intercept will shift up here. This will shift up 1, and this will shift up 1. So we get our new graph that looks like this. Whew, okay, so this right here is the graph of y equals 1 minus 3 sine of 2x plus pi. The one in the blue is what we are wanting. So that was quite the ordeal. You know what? If you're still with me, go ahead and print out a giraffe. Bring it to me on Monday. Get 1 point back on your last quiz.